Okay, so to help those who are still having a little bit of trouble deciding when they should use each of our anti-differentiation rules, we're going to go through, look at a couple examples and just look at the general idea of how we know which rule to use in which situation. Okay, so you'll remember this is the very first one we learnt. We spent a few lessons on that, and I very strategically made sure that the -1 for the power never came up. But as we know, these things do occur, and we looked at situations on what to do and how to get around that. So let's have a look at a few different questions. I've just randomly picked these out. Okay, I won't go through and solve all of them, but the idea is that you're getting the idea on where to go. So if I'm looking here, I've got 3x squared minus 6x plus 9, nothing to do with powers around the outside. So that immediately, when I go over here, tells me this isn't going to be useful to me, nor is this, because there is no -1, and again down here. The only one it can be is our original one, so we're going to add 1 to the power. We're going to write whatever that n plus 1 was up on the top, on the bottom. So let's quickly have a look at this one. So without doing all the communication, okay, I know that there'll be +1 to the power, so we'll end up with 3x n plus 1 will be 3 divided by n plus 1, which was 3. 6x will be the same, add 1 to the power, 6x, that would be a 1 already, 1 plus 1 becomes 2, and divided by the 2 on the bottom. And the last one, the +9, well, the x would be a x to the power of 0, so it would now be 0 plus 1, and likewise on the bottom. And of course we can simplify that by cancelling, so that will be x to the power of 3. And this will become -3x squared over nothing, and that will be 9x. Alright, looking at our next one, notice straight away we've got our expression and it's all to the power. Now you'll notice it is not -1, okay, so again, process of elimination, can't be this rule, can't be this rule. It does look very similar to this rule here though, okay. So again, you'll notice we're still doing the same idea. We're adding 1 to whatever the n value was. We're dividing by, again, in brackets the n plus 1, but we're taking whatever this constant was out the front and bringing it down. So in this case, we will do the same. So we're going to end up with x plus 2, adding 1 to the n value. We get 3. We need to divide by that n to the 1. So I know our n to the 1 was 3 up the top, and the constant out the front of whatever the x was, well in this case the constant was 1. So 1 times 3. So we end up with x plus 2 to the power of 3 over 3. Going to pause it there.